Welcome to Academic Daddy's class. There are some times when you see this type of thing drawn as the voltage and this type drawn as voltage as well. This thing, whenever you see it in this form, it means diamond form, and this diamond form means that it's dependent voltage. It's a dependent voltage. While if you see it in this form, this one, this normal one, it means that it's independent voltage. So note that. So if you see it this way, is independent. See, this way is dependent. So this is the same thing with. So let's go to our class. Today's class is on Thevenin theorem. So they said in this question that we should determine the currents in the 10 ohm resistor, this one. So to do that, I will open circuits. So if I open the circuit, I've told you there sometimes you don't know the answer. Once you write solution, inspiration will come. So let's open the circuit. I will draw. So instead of this, I open the circuit. I open the circuit there. So this is where I will stand and determine my VTH, making it sound. So this is what you have when you open the circuit. So now, in order to get the VTH, I will say standing here. So it's just like when you're doing Thevenin, you open the circuit, then you say looking inside. So if you are looking inside, if you are looking inside this, the only place you will see is just this part, just this part. Let me draw it. So this is the only part you will see if you are standing inside. But you need to now know that since you have this loop, the current that will be flowing here, there will be a current entering here and leaving this way, then entering this particular side and going up and then coming. If the current comes to go like this, it will come here. It will not continue because this place is open. So for that reason, current is only on this loop. So to determine Thevenin, we first of all have to find, because this current that is flowing here affects this 6 ohm, and this current that is flowing here will pass through this voltage. So we have to determine the current in this first loop. So look at that loop, so that we will now say this is what I mean. Just that loop is what I want to draw. This 12 volts. So we have the current moving here, leaving here. Then this is going around, coming here. This is the current that will be here. So let's say we call this I1. This I1 is what is here as well. So it's the I1 here. So 10 volts, 12 volts. Okay, I've already written it. So we use KVL, that is Kirchhoff voltage law. So to do KVL is simply, so let's say we are starting here now, entering positive. Okay, so see, it's going to be, yes, the way we normally do it, we can say, since we chose this part to be the point of entry, normally we normally say let it be going out. So we can just say let's pull out this one. See, is entering, and whenever it leaves through the negative terminal, it becomes minus 10V. This one will enter, leave through the positive terminal of this voltage, plus 12V. Then going up, now remember, this is 4 ohms, I forgot. So this is 4, but let's continue. So leave this way, then this should have been, okay, I can as well do this to be equals to all the voltages. Voltage, that is V, equals to IR, equals to, so since there are But the only problem is that this particular way makes us miss the direction, miss the signs. So let me just do it this way. Let's say as I started with the 4 ohms, then it's coming like this. Let's say I said 4 should be okay. So I think the problem why I'm having issues that I did not start with the positive voltage. If I'm doing it, I normally this is the positive voltage here, the one that left through this part. So let me start with 12V. This now, once it's moving this way, all the currents that is in the direction that is moving becomes negative, minus 6. Then the I there is I1. Coming to turn like this is still in the same direction. The current is still the same, minus 4I1. Then as it's coming down here, it's leaving through the negative terminal, minus 10V equals to 0. So I normally use this. I could have said all the voltage equals to IR, that is the current and the resistance, but I normally use this way so that we'll be able to include the signs properly. So you can now see that this is 12 minus 10, which is 2V equals to, this is minus 6 minus 4. On this side is going to be minus 10. If you cross the equality sign, it becomes 10I1. So V will be equals to 10 over 2. Okay, but it's not V I'm looking for. Yes, it's not V I'm looking for. But assuming I want to find V on this, the voltage here is 5 volts. But what I'm looking for is I. So I is going to be, I1 is going to be 2 over 10. And 2 divided by 10 is equals to 0.2. 0.2 amps. So this is what I'm looking for. So that means that as I've gotten this I1, we say that I1 is here, that I1 is here, I1 is here, that everything flowing here is I1. So we've gotten this I1. So this is now, this is having I1, this current is having I1. So the next thing is to determine the VTH. Now notice, it's better, this thing I drafted this thing here so that you'll be able to see what I am doing. So don't go and confuse yourself. So now that I've gotten this, if I want to determine the VTH, see, let's say I follow this direction so that it will be leaving through the, it will be, okay, yes, let's say it's going this way. And it's going this way. This will be leaving through the positive. I'm determining VTH now and I need to choose direction for my VTH. So let's say my VTH is going this way. You can choose any direction you want. Now if it's going this way, it's the same thing here. Notice that the current here already is this size. It's going this way. The current here, the current on this I1 is this way. And my VTH is, so this is going to be VTH. And to determine VTH is going to be, watch, I'm seeing, I don't have use for this, I'm seeing this is going this way, so it's going to be, so going by this, you can see that if this is going in this direction, VTH is going in this direction. So I've told you, once anything is going in the direction that thing is going to be negative. But notice that this is having to leave the positive axis, so it becomes plus 12. Then it's going in the same direction with this one, minus 6. This is I1 equals to 0. So it's not like saying it leaves through the positive, cuts through this, the same direction with it. Why this one is positive is because it left the positive side. So this is going to be the same thing as saying VTH, that is 12, equals to minus 12 plus 6, and I1 is 0.2. 6 times 0.2 is 1.2 equals to minus 12 plus 1.2. So VTH is going to be minus 12 plus 1.2. So VTH is equals to minus 10.8 volts. And we said that the minus sign in anything volts, current, and whatever does not matter. So it's the same thing as in VTH is equals to 10.8 volts. So because what it means is that we chose the wrong direction, because assuming we went this way, let's say we went this way, assuming we went this way, could have been, let's say I chose this direction, it could have been VTH, let's say I can use this direction, could have been VTH going in opposite direction plus 6I1 then minus 12. That is leaving here. Assuming I went this way, assuming I use this direction, it could have been, since this current here, see, assuming I use this direction, this is what I mean. Since this current here is going in opposite direction, this VTH is going in opposite direction to this current, it will be plus. So if you cross equality sign, it will show that it's going against it. So then it's leaving the negative terminal, minus equals to 0. So then you now see VTH will now be equals to, this 12 will become positive, this will become minus 6I1. So this becomes 12 minus 1.2 equals to 10.8 volts. So it depends on the direction. So whichever direction you choose, you get the correct answer. But if you see a sign that is negative, just know that it means that you did not use the right direction. We agree to that now when you are dealing with Thevenin. So this is the correct answer. So that's for the VTH. So when we've gotten the VTH, the next thing is to get the RTH, that's the Thevenin resistance, so that we can now get the current here. So to get the RTH simply means we short circuit, we make everything that is not a resistor here a wire. So this will now become, this is the place you are viewing from. So that voltage, you short circuit it. So if you do this well, what it means is that as you are viewing this from here, this is parallel to this, so 4 is parallel to 6, which is the same thing as saying 4 times 6 all over 4 plus 6 is equal to 4 times 6, then 24 over 10. That means RTH is equal to 2.4 ohms. So once you've done this, you now come and obey the rule of Thevenin. Thevenin's rule states that in a linear circuit, the total resistance is always in series with that is the Thevenin resistance, which is the total resistance, is always in series with the load resistance and the Thevenin voltage. In a linear circuit, the Thevenin resistance, which is the total resistance, is in series with the load resistance and the Thevenin voltage. Note that. So this is going to be the same thing as saying, let's apply that. So this is the Thevenin voltage, and we got that to be, what did we get it to be? 10.8 volts in series with RTH, and we got that to be 2.4 ohms. in series with the load resistance, which is 10 ohms. So now that we've gotten this, to find the current here, the current on this, which is RL, the current here will be the same current on this one. Currents in series, they are equal. So this is going to be the same thing as saying ITH will be equals to voltage over RTH plus RL, which is equals to 10.8 all over 2.4 plus 10, which is the same thing as saying 10.8 all over 12.4. 10.8 divided by 12.4. So the ITH, Thevenin voltage, will be Thevenin current, or the current in that 10 ohm resistance will be 0.87, which is approximately 0.9 ampere. So that's your answer. Academic that is close. So they say find the current in the 0.1 ohm resistor. So in order to do this, they say using Thevenin. So in order to do this, all I need to do is to short circuit that 0.1 so that it becomes so to get the VTH. This is to get the VTH, all I need to do is to say, since they say this current is going this way, that means it's entering like this. They say this current is entering like this. So for that reason, I have to say there's current going through this, and I'm talking about VTH. So I'll say the voltage inside this particular loop, this now, current that will be touching here, using KVL, Kirchhoff voltage law, it will be the same thing as in VTH minus IR here. The I that is entering here is 5. The R here is 0.5. Now check something. We need to take our, let's say we are taking it that this is the first I, this is the first I1, and this is the second I2. So let's say our VTH is going this direction. Now VTH is going this direction. So you see that it's going the same direction with this current. But as it comes here, it's going in opposite direction with this one, with this 2 ampere, because this one is coming down, it is going up. So it will become plus. Once you notice the direction is different, it becomes plus. So plus voltage is equal to IR. The I here is 2. The R here is 0.4. So everything equals to 0. So 5 times 0.5 is equals to VTH minus 2.5. So plus 2 times 0.4 is equals to 0.8 equals to 0. VTH, making subject of the formula, this will be equals to, we normally do this way so that by the time you cross equality sign, this will change to positive because it will now show that they are going in the same direction. So it will now be 2.5. VTH is equals to 2.5 that is going in this direction. That is because this current is going in the same direction. Why this one is going in opposite direction? So that's why we normally do it, so that by the time you come out, it's now show that it's in opposite direction. So punch this, you now have 2.5 minus 0.8. So VTH is equals to 1.7 volts. Now for the RTH, to get the RTH, we come back here, have this, because I have this now, RTH. But the only thing is that when it's RTH, when it's RTH, I will notice this thing that I have here, 0.5. Zero 0.4. This thing that I have here, that is the current, I will short circuit it, turn it to a wire. Short circuit it, turn it to a wire. Whenever you are finding RTH, you turn to a wire every external source. So it's like this. Now notice that this RTH is now like this with this. This is series. So this RTH is simply equal to 0.5 plus 0.4, which is equal to 0.9, should be. That's RTH. So we'll go back and obey the rule. Thevenin's law states that in a linear circuit, the total voltage, which is the Thevenin voltage, VTH, is always in series with the total resistance, which is the Thevenin resistance, and in series with the load resistance. So this is it. So we got VTH to be 1.7, got RTH to be 0.9. Our load resistance is 0.1. So if we put this together, we now see that to find the current will simply be the ITH will be VTH over RTH plus RL. This will be the same thing as saying the current that will be here is the same current will be here. Anything in series has the same current. So this is going to be 1.7 all over 0.9 plus 0.1 equals to 0.9 plus 0.1 is that one. So equals to 1.7 over 1, which is equals to 1.7. That's your answer.